I'd like to talk to you about drift and droplets. I wished I could interact so that you can reply, because I'd like to ask a question. And what's the most important factor in drift mitigation? You notice I'm not saying drift reduction, I'm saying drift mitigation. It's about droplet size. The biggest factor is not wind, it's not anything else other than the size of the droplet. If you have a 100 micron droplet versus a 200 micron droplet, that 200 micron droplet is 8 times more volume than the 100 micron droplet. So a lot of people think that it's just the double of the size is the double a droplet, but you're actually increasing the volume 8 times. So another misconception is when you're trying to retain solution on the plant, because not only do you want to mitigate drift by increasing the droplet size, you want to be able to retain it on the plant, so you can increase deposition, but if it's not retained on the plant surface, there's no efficacy unless your soil is the target. So when you're spraying a product, water, you can affect droplet size by nozzle selection, pressure, wind speed, environmental factors, boom height, multitude of other reasons. You can't affect how water breaks apart unless you put something into the mix to do this. Traditionally, a surfactant, which is a surface active agent, or oil reduces the surface tension of the water, which when you relax that droplet and it exits that nozzle under pressure, you get smaller droplets. So smaller droplets are not necessarily good unless you want coverage, like with a contact type of a pesticide like Permoxone. Most of the pesticides that we use today are systemic, so it's more about getting the product to the target and retained on the plant. With the addition of polymer-based drift mitigation adjuvants, which provide the most significant factor in mitigating the droplet size, when that water breaks apart as it exits under the nozzle under pressure, you get a slightly bigger droplet. Now people will say, well, you want to narrow that droplet spectrum, you want to narrow the range of the droplet size, or you want all the droplets in this range. And I would counter by saying, as long as you keep that droplet size above 150 or 200 microns, then the other bigger droplets are important for a number of reasons. If you have a dense crop canopy and you spray everything at 150 microns, that droplet's just going to lay on top of the first foot of that corn plant. If you increase that droplet size to 300 microns, you still, the difference in the size is this big versus that big. So you really can't see the difference in the droplet on a piece of paper. You can see better deposition into the canopy. So if you're spraying any type of product, especially the fungicides, you want coverage, not because the fungicide isn't systemic, but because you want to also cure any fungus that might be down into that ear where the ear or the flag leaf is. So it's very important to have a range of droplet sizes. So a bigger droplet isn't bad, it's just a lot of products that are used like a surfactant or an oil that really might narrow the range of the droplet spectrum. They really reduce the size. As we discussed in another video, if you exit that solution under pressure out of the nozzle, you break apart. If that water's relaxed, it breaks apart easier, which means you create more droplets. So droplet size is the most important factor in drift mitigation. Thank you.